Hi, my name is Krishna Jha. My Coventry ID is 1761983 and this is my project for Introduction to Programming CryptoSteg version 3.0. CryptoSteg is a Python desktop application that lets you hide a secret encrypted message inside an ordinary image file. So from the outside the image looks completely normal, but it's actually carrying hidden data inside it. Over the next few minutes I will explain how it works, walk through some of the code and then show it running live. So what it does, how it works. The tool combines encryption and steganography. First, your message is encrypted using AES-256 with a password you set. So it's already scrambled and unreadable before it ever touches the image. Second, that encrypted message is hidden inside the image using LSB steganography, least significant bit. Every pixel byte in an image has all these significant bit and I replace that bit with one bit of the encrypted message. Since it's only the smallest bit being changed, the image looks completely identical to the human eye, even though it's now carrying hidden data. This matters for cybersecurity because steganography can be used to communicate covertly, but it can also be abused to hide malicious payloads inside seemingly harmless images. That's exactly why I built a detection feature into this project. So the tool works both offensively as a way to hide data and defensively as a way to catch it being hidden. So to make this project I used a few key libraries. For the interface I used Tkinter, Python builds in GUI toolkit. That's why the app has its tabbed windows layout with encode, decode, detect and activity log sessions. For the encryption I used PyCryptodome, especially the AES cipher to implement AES-256 encryption and decryption of the message using the user's password. For reading and manipulating image pixel data, which is the core of the steganography, I used Pillow, the Python imaging library, along with NumPy to handle pixel arrays efficiently as numerical data rather than looping through them manually. And for the reporting feature, I used Report Lab to generate PDF. Before I demo it, let me quickly show how the project is structured because I deliberately separated the logic from the interface. Inside core, I have encryption.py, which contains my AES-256 class. This handles generating the encryption key from the password and doing the actual encryption and decryption operation. Separately, steganography.py contains the LSB logic, the code that actually reads and writes individual bits into the image pixel data. I kept these two completely independent to each other so the encryption code has no idea it's being used for steganography and vice versa. Each one could be used in a totally different project. Now let's see all of this working live. I will encode a message, decode it back out, run detection and show the exactly activity logging. So to encode the image, first we browse. I am choosing this image and we are going to write the secret message we are going to give another person. And we are going to put a password. Now we are going to save this image as stego image 6. Now the message is successfully hidden. Now the decode tab, I select the stego image I just created, stego image 6. Here I am going to put that password which I gave earlier. You can also see that if I will put the wrong password, the file will not open. Here, yes, wrong password and corrupted data. If we can, and now I'm going to give a correct password. Now you can see that message extracted and decrypted successfully. Hello, my name is Krishna Jha. Now the detect tab. This runs a steganalysis check to estimate whether an image contains hidden data without needing a password. I will select the stego image. Now result displays confidence score 100%, which means that the report shows the LSB distribution across red, green and blue channels. How many bits are 1 versus 0 and the row between them. A ratio close to 0.5 suggests either a natural image or encrypted data. Since encrypted data looks statistically random. If now in the activity log, finally the activity log tab, every encode, decode and detection action is automatically recorded with a timestamp, action type, file name and results, giving a full audit trail. I can export this as PDF. This generates a clean formatted document of the activity story, which would be useful in a real investigative or auditing context. Now I am going to also one more important thing. All of this project I have put it in the GitHub. I used GitHub throughout development to version control this project. You can see this CryptoSteg. Also you can see the 9 comments made over the development period, tracking the project as I built out the core encryption module, the steganography logic, the GUI and later fixes and updates. This gave me a safe history to fall back on if something broke while I was building later failures. So that's CryptoSteg version 3.0 combines AES-256 encryption and LSB steganography to hide secret messages inside images with a steganalysis detector, activity logging and PDF reporting. Throughout building this, I focused on keeping the core cryptography and steganography logic separate from the interface layer so each part could be built and tested independently. Thank you for watching.